We're going to look at the universal wave equation and do some problems with it. Before we do, I just wanted to go over the relationship between frequency and wavelength. So if I create a wave with a very high frequency, I should get something like this. And then if I move my hand so it's a little bit lower frequency, I get something like this. So the universal wave equation sums up this relationship. And it says that the speed of a wave is equal to its frequency multiplied by its wavelength. And if I have the same medium, that speed's going to be constant. So then what happens is if I multiply these two, I should get a constant. So when I increase one, like my frequency, in order to keep this constant, the wavelength must decrease or become shorter. And the reverse would happen as well. So if I decreased my frequency, my wavelength would increase or get longer. So that is a very important relationship between frequency and wavelength for a constant medium or speed. So let's do an example. In this question, we have a wave in a rope, and it's traveling at a speed of 2.5 meters per second. If the wavelength is 1.3 meters, what is the period of the wave? So I always start with our givens on the left-hand side. And what we know in this question is the speed of the wave, which is v. I also know the wavelength, which is lambda. And I want to find the period, which is t. So I keep the formulas handy when I'm doing these problems that we have on the slideshow and on our formula sheet. And if we do, we'll notice there's no formula that relates speed, wavelength, and the period. There is one, however, that relates speed, wavelength, and frequency. And if I know frequency, I can easily find my period because it's 1 over, or the inverse of the frequency. So what I'm going to do is first find the frequency, and it's quite quick to take the inverse of the frequency and get to the period. So whenever we know one of these values, we can easily find the other. So now that I know that, I'm going to write the equation that I'm going to use, which is the universal wave equation. And I'm looking for frequency. So what I want to do is get rid of lambda. I'm going to divide both sides by lambda, so it will cancel out on my right-hand side and move it over to my left-hand side. And then my frequency will be equal to speed over wavelength. And since I've listed my givens over here, I can easily sub those in and solve. So my speed will be 2.5 meters per second. Wavelength is 1.3 meters. The meters cancel out and I'll be left with 1 over seconds, which is my units for frequency because that is the same thing as hertz. And if you divide these, you should get 1.92 hertz. I like to keep a few extra digits when I'm going to do another calculation, and then just round once. And then I can find my period by taking the inverse of frequency, which is 1 over 1.92 hertz. 1 over seconds will give me seconds, and the answer to that is 0.52 seconds. And then you just do their first statement and you'd be done.